Hi, my name's Raza.
And I'm Nolan. Today we'll be talking to you about Newton's three laws of motion.
These three laws are the law of inertia, the law of acceleration, and the law of symmetry in the forces.
We'll be showing these laws through various different demonstrations.
Some would argue that the greatest scientist of all time was Sir Isaac Newton. He was clearly a genius, as over the decades he lived, he concluded his research of his three laws of motion. Newton's first law, sometimes referred to as the law of inertia. It is stated that a body remains in a state of rest or uniform motion unless it is acted on by an external unbalanced force. What this means is that all objects that are at rest or are in motion have a certain amount of inertia that never changes, and so let's give you an example of that. It's hard to see Newton's laws at work when you have gravity, friction, and air resistance at play. So let's say all the gravity and friction and air resistance is gone for a moment. Now if I push the skateboard along the ground, it will remain in a state of constant motion. It is assuming that there is no friction at all. Now let's bring back all the gravity, friction, and air resistance. It simply stops moving. Now if gravity, friction, and air resistance were gone again, and this skateboard were to be pushed by an unbalanced force and it hit an object, in this case a wall, then it would stop moving. If that wall wasn't there, that skateboard that had been pushed would just keep on going and going in a straight line and never slow down. It would just remain in a constant state of motion, never going off course and never stopping according to Newton's law. This is what happens in space. When you see planets being destroyed, the explosion is the unbalanced force which pushes all the objects in the space like meteoroids, and then they're in a motion and they do not stop as there is no gravity, friction, and air resistance, and it just keeps on moving and moving and moving forever according to Newton's first law. And so if you're in rest, then you will remain in rest. If you're in motion, then you'll remain in motion unless you get acted upon by an unbalanced force.
Now, let's head over to Newton's second law of motion, which is arguably the most important of all the laws. The reason for this being is that we get a number of formulas from this which help us calculate how and why objects move. And so the second law defines how the acceleration of an object is directly proportional to the force acting upon it,
and is inversely proportional to the mass of the object.
The best way to remember this law is to memorize the following formula. Force equals mass times acceleration. So let's take a bowling ball and apply a force to it. If I do that, then it will accelerate. Now, let's take a tennis ball and apply the same force to it. The tennis ball accelerates a lot quicker. This is due to a smaller mass in the tennis ball. This can also be shown by pushing a skateboard with a bucket of water on it compared to pushing a skateboard with nothing on it. The board with the water on it has a higher mass, therefore it doesn't accelerate as quickly. The reason for this is that if I have a bigger mass and I apply the same force to it, I'm going to get a slower acceleration. The equation force equals mass times acceleration can be used to do a lot of calculations. Also note that if I apply a force in this direction, that's a vector, which means that it has a direction and a magnitude, which means that I'm going to get the acceleration in the same direction. So I could keep, for example, my mass the same and apply a greater force to it. I'll get a greater acceleration than if I had the same mass and a lesser force. Now that concludes Newton's second law of motion.
Now let's head over to Newton's third and final law. Newton's third law is sometimes referred to as the law of action-reaction pairs. So his third law of motion states that for every action there is an equal and opposite reaction. For example, if I was to push my thumb against the wall, not only am I pushing the wall, but the wall is also pushing back at me now. You probably think that's weird or silly, but for my example, I'm now going to take a spring-loaded trolley and have it pushed against the wall, and then the trolley would go the other way since the wall is going to push it with an equal force in the opposite direction. This law is used for all kinds of situations.
For example, if you drop a tennis ball onto the ground, the ball will apply a force downwards. The ground is applying an equal and opposite force to push the ball back up off the ground. That is why a tennis ball bounces. Now that brings us to the conclusion of Newton's third law of motion. Just remember, For every action, there's an equal and opposite reaction. That's Newton's 3 laws of motion. Thanks for listening to mine and Rise's project on Newton's 3 laws of motion.